Hello everyone, let us start networks. It is estimated that by 2016 there will be over 20 billion fixed and mobile network devices. So the day by day the mobile networks are increasing. This affects traffic volume in number of ways. It enables a user to continuously consuming network capacity. So many users are continuously consuming the network. Capacity can be consumed on multiple devices simultaneously. Multiple devices try to access the network simultaneously. Different broadband devices enable different application which may have a greater traffic generation. That means some devices have a greater traffic generation than other devices. Then LANs, especially Wi-Fi LANs, the Wi-Fi what we have in our home, are also increasingly used for small office and home networks. Since online classes have started, so many houses are using Wi-Fi LANs day by day. So it causes a challenging to us. That challenge is that interconnecting and managing diverse connection of all LAN networks and computing devices within today's business. We have to connect all the LAN networks of today's business. Then comes networking. Advances in technology have led to greatly increase the capacity and concept of integration, allowing equipment and networks to work simultaneously. We have to integrate equipment and network so that they can work simultaneously. We have to integrate like voice, data, video, image. Wide area networks. Wide area networks includes all large geographical area. It spans a large geographical area, requires the crossing of public right of ways. Okay. Rely in a part on common carrier circuits. It relies on a common carrier circuits. Typically, it consists of number of interconnected switching nodes. There are many switching nodes which are interconnected, so that one wide area network work properly. A transmission from any one device is routed through these internal nodes to the specified destination device. If we want to transmit some data from one device to the another device, there are routers that is called internal nodes. These nodes are not concerned with the content of data. Nodes have nothing to do with the content of data, rather their purpose is to provide switching facility that will move the data from one node to the another node until the destination is reached. Okay. So wide area network uses alternative technologies like circuit switching, packet switching, frame relay and asynchronous transfer mode, that is also called ATM. While ATM to some extent frame relay are still used widely, their use is gradually supplemented by services based on gigabit Ethernet and Internet protocol technology. There are two new technologies that have been supplanted the use of ATM and frame relay. Those are gigabit Ethernet and Internet protocols. Coming to circuit switching, it is like circuit switching is an old method. Okay, a dedicated communication path is established between two stations through nodes of network. Here also there is a nodes between. A dedicated communication path is established between source and destination through nodes. Path is connected sequence of physical links between the nodes. There is a physical link between the nodes in circuit switching. Okay. On each link, a logical channel is dedicated to the connection. Each link has a logical channel dedicated to the connection. Data generated by the source station are transmitted along the dedicated path as rapidly as possible. Data is generated by source station and then it is transmitted along the dedicated path to the destination. That is, there is a dedicated path. The most common example of circuit switching is the telephone network. So circuit switching is mainly used for the communication, that is when the data is voice. Okay. If you want to transmit a voice, we use circuit switching. Then we have, it is a diagram, then we have packet switching. Data are sent out in a sequence of small chunks called packets. A data is divided into small packets. Packets are passed from node to node along the path leading from source to destination. There is a path from source to destination, dedicated path from which data is, that is packets are passed. In the internal there is nodes. Each packet is passed from one node to another node to then it is passed to destination. At each node, entire packet is received, stored briefly, and then transmitted to the next node. At each node, a packet is received. A node has nothing to do with what is inside the packet. It just in each node, entire packet is received, stored, and then passed to the next node. Okay, then packet switching networks are commonly used for terminal to terminal computer and computer to computer communication. Packet switching is used for terminal to terminal computer and computer to computer communications. This is a diagram. Then what are the issues with the packet switching? Packet switching is an old method, okay. Packet switching was developed at a time when digital long distance transmission facilities exhibited a relatively high error rate compared to the today's facilities. Packet switching was introduced when there was a lot of error in the communication, okay. As a result, there is a considerable amount of overhead built into packet switching schemes to compensate for errors. Those errors are compensated by packet switching. The overhead includes additional bits added to each packet to introduce redundancy and additional processing at the end stations and the intermediate switching nodes to detect and recover from error. The overhead includes additional bits added to each packet to introduce redundancy. An additional bit is added to each packet to introduce redundancy and additional processing at the end station, okay. Then intermediate switching nodes to detect and recover from the error. Then the original packet switching networks were designed with a data rate to end user of the about 64 kb per second, which is very small. Then we came up with the frame relay, developed to take advantage of high data rates and low error rates. We wanted to transmit data very fastly, so we wanted high data rates and low error rates. That's why we came up with the frame relay. Operates at a data rate of up to 2 MB per second. Frame relay operates at the data rate of 2 MB per second. Key to achieving a high data rates is to strip out most of the overhead involved with the error control, okay. Then asynchronous transfer mode, ATM, referred to as a cell array. ATM is also referred to as a cell array. Culmination of developments in circuit switching and packet switching. It includes both circuit switching and packet switching. Culmination of development in circuit switching and packet switching. The difference between frame relay and ATM is that frame relay uses variable length packets, while frame relay uses variable length packets called frames, while the ATM uses fixed length packets called cells. By using a fixed length, the processing overhead is reduced. By using a fixed packet length, the processing overhead is reduced. Works in a range of 10 second and 100 second of MB per second in the GB per second range, okay. Allows multiple channels with a data rate on each channel dynamically set on demand. Allows multiple channels, ATM allows multiple channels with the data rate on each channel dynamically set on demand. According to the user demand, we set a data rate on each channel. It can be anything for 2 MB per second, 5 MB per second, like that. So difference between packet switching and circuit switching. In packet switching, data is divided into packets and packets is sent independently. One packet has nothing to do with another, it is sent independently. In circuits, there is a dedicated path for each packet in a circuit switching. There is a dedicated path for each packet in a circuit switching. In packet switching, data is processed at all intermediate nodes, including the source system. Data is processed at all intermediate nodes, including the source nodes. In circuit switching, data is processed at the source system only. The data is processed at the source system only. The delay between data units in packet switching is not uniform. The delay between data units in circuit switching is uniform. Packet switching is less reliable, circuit switching is more reliable, okay. Transmission of data is done not only by the source but also by the intermediate routers. Transmission of data is done not only by the source but also by the intermediate routers. In circuit switching, transmission of data is done by the source only. Less in packet switching, less wastage of resources. Wastage of resources is more in circuit switching. In packet switching, there is no physical path between the source and destination. In circuit switching, there is a physical path between the source and the destination. Packet switching requires a complex protocols for delivery. Circuit switching requires a simple protocols for delivery. Latency is high in packet switching, latency is low in circuit switching. Overhead is more in packet switching, overhead is low in circuit switching. LAN. LAN means local area network, that is nothing but Wi-Fi or Bluetooth. Smaller scope, typically a single building. We can use the Wi-Fi only in a single building. It is a smaller scope. LANs are usually owned by the same organization that owns attached devices. So LANs are usually owned by the same organization that owns attached devices. Most common configuration are switched LANs and wireless LANs. Internal data rates greater than WANs. Data rates are greater than WANs. The Internet involved from ARPANET, Advanced Research Project Agency of US Department of Defense. Developed to solve the dilemma of communicating across arbitrary multiple packet switched networks. Foundation is the TCP or IP protocol suite. Key elements of the Internet: wide area network, local area network, router, a standalone mainframe, local network area, Ethernet switch, router, LAN PCs and workstation. The purpose of Internet is to interconnect end systems called host. This includes PCs, workstations, servers, mainframes. These networks are in turn connected by routers. Each router attaches to two or more networks. Some hosts, such as mainframes or servers, connect directly to a router rather than through a network. In essence, the Internet operates as follows. A host may send data to another host anywhere on the Internet. The source host breaks data to be sent into sequence of packets called IP datagrams or IP packets. Each packet includes a unique numeric address of the destination host, referred to as an IP address. Based on this destination address, each packet travels through a series of routers and networks from source to destination. Each router, as it receives a packet, makes a routing decision. So this is simplified view of portion of Internet. Internet terminology. Central office, CO. The place where a telephone companies terminate the customer lines and locate switching equipment to interconnect these lines with other networks. Customer premises equipment. Telecommunications equipment that is located on the customer's premises. Internet service provider, a company that provides other companies or individuals with access to or presence on the Internet. Network access point, one of the several major Internet connection points that serve to tie all ISPs together. Network service provider, a company that provides a backbone services to an Internet service provider. Point of presence, a site that has a collection of telecommunications equipment, usually referred to as ISP or telephone company sites. That's it.